Hi students. Now we're going to be talking about law of cosines, and we have so far talked about solving right triangles, and then we got into the issue of what if we don't have a right triangle, how do we solve for missing angles and sides, and that's what brought us to law of sines. But you can see that maybe there's a case where you don't have a full ratio and you can't use law of sines because you have too many unknowns. And so that brings us to law of cosines. So it's just a different formula to use to solve for a triangle. So right now I'm going to go ahead and show you where law of cosines was derived from. And once again, we're going to go ahead and create a good old triangle. So an oblique triangle. I'm going to label this A, just to do something different. That guy B, C, and this one B. And now I'm going to go ahead and drop down the altitude. And so we have that this side length would be B, this side length is A, and this whole length is C. We'll name this H once again. And what I'm going to do is label this piece X, just any random variable. And if this whole length is C and this portion is X, then this piece has to be the whole minus the portion. And so what we're going to do is we're going to focus on this shaded right triangle, right? There's three triangles we see here. We see two right triangles and a big oblique triangle. And so what we're going to do is good old Pythagorean Theorem with this shaded triangle. So that would be x squared plus h squared equals b squared. And now we are going to go ahead and do, so fun doing these notes when I'm sick. Now we're going to go ahead and do a Pythagorean Theorem with this unshaded right triangle. And so that will be h squared plus c minus x squared equals a squared. Now I'm going to clean this up a little bit. So this is going to be h squared plus c minus x times c minus x equals a squared. H squared plus, when I FOIL this, I get plus c squared. I get a negative xc and then another one, so I have 2. And then negative x times negative x is x squared. Excuse me. So now, if you'll see here, we have this h squared plus x squared, right? Well, don't we have that up here? So what I can do is I can replace it, and just so I don't lose you, I'm going to go ahead and just rearrange this. So I could say this is x squared plus h squared plus c squared minus 2xc equals a squared. So this is the same thing as this, just rearranged. Well, here this piece is again, so now I can replace this with b squared because it's equal to b squared. So now I have, okay, b squared plus c squared minus 2xc equals a squared. Well, now I think I can maybe replace something else. So what I'm going to do now is I'm going to go ahead and stand here, and I'm going to go and say, what is cosine of A? And the reason I'm doing cosine is because it's law of cosines, and that's where I know this formula is going. So cosine of A of this right triangle would be adjacent over hypotenuse. Well, I want to solve for x, so I'm going to multiply both sides by b. So now I have x equals b times cosine A. So now what I can do is replace x, here's an x, right, with b times cosine a. So now I have b squared plus c squared minus 2 times b cosine a times c equals a squared. This is a beauty, huh? This is actually law of cosines. I'm just going to clean it up a little bit. So there's 3 different formulas for law of cosines. So it's a squared equals b squared plus c squared. So it's side length squared equals the 2 other side lengths squared minus 2. I'm just going to write these next to it. 2 times the 2 other side lengths times cosine of the respective angle. And here is law of cosines. All right. So we solved for this one, but again, we could have dropped that altitude down from another vertex and could do the same exact proof to solve for the other 2. So you just use accordingly to whatever the problem gives you. And so this is telling you, brain, where did you go? This is telling you the cases that you can use law of cosines on. Again, you're not going to memorize that. Your first go-to is law of sines. If you don't have a full ratio, then you're going to be forced to use law of cosines. Now, when you use law of cosines and then you get a full ratio, I am begging you to keep using law of cosines. Do not jump to law of sines. I'll explain that in class. There's a problem that happens. So what I'm going to do is, okay, so we have here A is 2, C is 1, and B is 10. So again, if you're like me and you need a visual, please don't give up on that. It doesn't matter how you draw your triangle. A is 2, C is 1, and B is 10 degrees. So you can see how you definitely don't have a full ratio. And this is not a right triangle, so I cannot use Pythagorean Theorem to find that missing side. So it looks like because I have angle B, I'm going to be wanting to solve for side length B. So I'm going to be using that middle equation. So I don't know this, so it will be B squared equals A squared plus C squared minus 2 times A times B cosine 10 degrees. And you're just going to go ahead and do that in your wonderful calculator, and you get B squared is approximately 1.06. But don't forget, you have to take the square root because this is squared. So we end up getting about 1.03. And I know I said in the previous video to the tenths. I think I'm going to change that to hundredths. It's more accurate. We'll be consistent in class, so you'll get used to it. Now, we have to solve for the other things, right? So now we know that this piece is 1.03. Well, I need to solve for an angle. So it's whatever angle your little heart wants to solve for first. I'm going to go ahead and choose to solve for A. So because I'm solving for angle A, I'm going to use this equation. So I have A squared is 2 squared equals B squared, which is, now on my paper I have 1.03, but what I'm really going to do is on my calculator use the entire answer, and we'll go over that in class too. Plus 1 squared minus 2. I'm going to go to my calculator and select the entire value and not put in 1.03. Cosine, and I don't know A. Okay, so when you clean this up, this right here and this, they are not like terms. So I can't just go ahead and calculate. I have to go slow. So I have 4, and I'm going to use approximately, actually, because on my paper I'm rounding this value. All right, when I go ahead and take care of this first part, I get 2.06 minus. Now when I take care of this part, I get 2.06 cosine A. Then I have to go ahead and take away 2.06. And I'm going to go over here. So I get 1.94 is approximately negative 2.06 cosine A. Now I have to go ahead and divide by negative 2.06. Really need to work on writing smaller. I'm going to go up here now. 1.94 divided by negative 2.06 is negative 0.94 is approximately cosine A. Now remember, to find an angle, you have to use the inverse. So inverse of negative 0.9, whoops, not that. Let's go ahead. Negative 0.94 will give me A, and I end up getting 160.29 degrees. And to solve for the third angle, so we have the one side, right? We have one angle, and to solve for the third angle, well, we know the other one's 10 degrees, so it has to be the leftover of 180. So that's angle C. Again, is approximately, since I had to approximate A, 180. Let me go ahead. I'm going to get better with this as the term goes on, I promise. So we're doing angle C. So I'm going to just go angle C is 180. Take away the 10 plus the 162.29. So angle C is approximately 9.71 degrees. Gosh, my handwriting is so much better in class. Okay, so that's how you solve for law of cosines. And then we just have two more. And what we're going to do is we're going to do this one. Actually, we'll go ahead and do both. All right, so this one. All my side lengths are 2. What kind of triangle is this? An equilateral. So you could do law of cosines all you want, but if you remember your geometry days, an equilateral triangle means all your angles are equal, which forces them to be 60 degrees. So simple. Okay, so this one. Again, it looks like we're going to have to solve for A first because we have angle A is given to us. I know I can't use law of sines. I do want to think about that, even though we're in law of cosines section, because on the exam, it's not going to be broken up by sections. But I don't have a full ratio. I don't have a little b and a big B, a little c and a big C, or a little a and a big A. So it forces me to use law of cosines. Okay. So here we go. We are going to do a squared equals b squared plus c squared minus 2 times b times c cosine 120 degrees. I love these kinds because they are just very straightforward. And what I end up getting is 21. And you could put the, you could go ahead and put the decimal, but what's really nice is if you can, always keep the whole value. It makes calculating way easier and more accurate. So I would like to see it as a square root of 21. I didn't do that before because it was a decimal, but you could have. You could have said, okay, this is the square root of 1.06. And so now we have A. So now it's up to you if you want to solve for angle C or angle B. I'm going to go ahead and solve for angle B. So I get 4 squared equals, see, this is why it makes it easier, because that squared is just going to be 21, which is nice. Plus, and I should mention you'll be given this formula. You don't have to memorize it. Minus 2 times A cosine B. Now just make sure you realize that this and this, they are not like terms, so you have to do it step by step. So I get 16 equals 22 minus 2 root 21 cosine B. Take away the 22, you get negative 6 equals negative 2 root 21 cosine B. Divide by negative 2 root 21. Do this in your calculator. Let's see. So now, okay, so I have cosine B. I'm just going to leave it as 2 over root 21. Negative divided by a negative is positive. And again, because I'm solving for an angle, I need to do the inverse. Notice here it's a straight equal sign because I haven't done any rounding. But now, once I find it in my calculator, 49.11 degrees. So I put it approximately. And to solve for that third angle, 180, take away the 2 angles you have. And we get 10.89 degrees. And that is law of cosines. Okay, see you in class.